Both are convex lenses. Both are convex lenses. So when you say a convex lens is a thin lens, you are basically saying that the thickness of the lens is low. When you say it's a thick lens, of course, you're talking about the thickness of the lens is high. Lens is high. Okay, now this one is what refers to the thickness. So you can see the red line which I've drawn is what is referred to as the thickness. Okay, now I also want you to know this. Look at what I'm trying to do. Okay, look at what I'm trying to do. Okay, this is a reference line. The green line is a reference line. The green line is my reference line. These are all ideas. All right, and in physics, you must have a lot of ideas. You must be very creative to analyze things properly. That's a reference line. So the same goes for here. That's your reference line. So what am I getting at here? Here, I want to introduce another concept. Okay, this is what we call curvature. I'm going to give you what we call curvature of the lens. Curvature of the lens. So curvature of the lens is how curved is your lens. Follow my finger. How curved is your lens? That's the curvature of the lens. So you can see, you can use that as your reference point. So you can see that, use that. Okay. Now look at that. Look at that as your reference point. This one is bigger. If you look at the angle, so to speak, bigger angle. This one is smaller angle. So this is what we. So this one is bigger curvature or smaller curvature. This is bigger angle means bigger curvature. Bigger curvature. That means it's curved a lot. Small angle means smaller curvature. That means this is smaller curvature. That means that lens is curved by a small angle. All right, lens is what you call curved by a small angle. That is another way of looking at a curvature, the right way of looking at a curvature. So make sure you are able to view curvature as how I said. Now, the curvature is often related to the radius. It's often related to the radius. So now we are talking about the radius. So again, curvature is often related to radius. All right. So now, how do we look at the radius? So remember, this is the curvature of the lens. So remember, this is part of a big circle. Sorry, part of a circle. This is part of a circle. So if you visualize, all right, with this curve, you are going to get a very small circle, meaning a circle with a smaller radius, or this one will give you a circle with a smaller radius. That is next you got to visualize. That means if I were to go along this curve and complete it into a circle, will that circle give me a smaller radius compared to that, or give me a larger radius compared to that? So you go and complete the circle. Go and complete the circle. So from here you should know this smaller radius. This means larger radius. So now we have what we call a complete understanding. A larger radius means smaller curvature. All right? Larger radius means smaller curvature. A smaller radius means bigger curvature. Smaller curvature means the lens, all right, just deviates from its reference line by a small angle. Bigger curvature means the lens deviates from the reference line by a bigger angle. So you should not have any problems when words like thickness, curvature, all that is introduced to you, questions, you should be able to understand, or you should be able to know what they're talking about. And last lesson, I also introduced another concept. I said diameter of the lens. I also introduced this. Diameter of the lens. Let me recap that as well. Is that the diameter of the lens? No, this is the thickness of the lens. What are you looking at? You're looking at the lens from the side view. This diagram shows lens from the side view. So you're looking at the lens side view. So if I were to take, see, this is the lens. You're looking at the lens this way, side view. If I were to twist the lens, turn the lens and bring it like that, that will be the front view of the lens. So that means you're looking to that way. If you look at that, your lens usually is taken as a circular shaped lens. So it is taken as a circular shape. It is taken as a circular shaped lens. All right. So that's the diameter of the lens. So diameter is that. So this way is the thickness of the lens. So if you want to orientate these two, that means we are looking at the lens from this way, how thick the lens, that's the thickness. That's a front view, that's the diameter of the lens. So I already cleared all these ideas and understanding of a lens so that you know exactly what the lens, exactly what the property of a lens, what are the properties of the lens and how do you refer the lens to. Okay, all right. So remember, thick lens must be associated with short focal length. Short focal length must be associated with near viewing for reading purposes. Thin lens must be associated with long focal length. Long focal length must be associated with far distance viewing. All right. You see, for far distance viewing, you need what you call a low power. So this must be associated with low power. That means for far distance viewing, we need low power. So we need a low power lens. We need a low power lens. All right. For far viewing, we need a low power lens. For near viewing, you need a high power lens. So whenever you're reading the book, remember your lens, your eye lens is adjusted to high power. So high power, that is why after reading for a very long time, your eyes becomes tired because you are under high power. But whenever you look at distant objects, your eye seldom gets tired because you are using a low power and viewing. So all these must be associated. Why does a long, far or distant viewing need low power lens? Because only a low power lens can bring to focus far or distant objects. Far or distant objects can be brought to focus to our, near our eyes can be brought to focus to our eye, into our eye, can be brought to focus into our eye by using a low power lens. A low power lens can do that. They can focus far distant objects into our eye. All right. Near objects cannot. They can only do it to high power lens cannot. They only can do that to near objects. All right. They only can do that to near objects. So and vice versa. Okay, done.